Welcome, ladies and gentlemen. Let me introduce myself again. My name is Tomáš Pastrňák. I am CEO and founder Energon Advanced Energetics. And today I prepared two case studies about battery storage system, what we are doing in the last 2 years. In the beginning, let me introduce shortly about something about the company. Our company is pure Czech company. We are located in the Brno. As you heard before, we are focusing on the large-scale battery storage system. And let's say our main key benefit, what we should bring to the customer, our solution is tailor-made solution, which is, let's say, follow up the customer requests in the project. So this is our key benefit, what we can provide the customer. Let's start to the first case study. First case study, it's located in the Czech Republic, in the South Moravia. This case study have battery storage system plus PV power plant, and all this located in the production facility, we can say installation behind the meter. So shortly about some key technical things, what is installed there. So the battery storage system, the numbers of the battery storage system, there is 240 kilowatt power and 1.1 megawatt hour capacity in the lithium-ion batteries. One PV roof system, which is 245 kilowatt peak. The main consumption or own consumption of the production facility, it's around 220, and with the peaks 200 kilowatts and several days this peak. And of course there is no influencing of the actual electrical installation. The battery storage system and the PV, it's connected to the actual electrical installation without some big costs. Regarding the price of the system, both system, battery storage and PV, cost around 690,000 euro. And for this project was used the public subsidiary, which bring 480,000 euro for this project. Installation of the battery storage system itself bring several benefits for usage of the PV on the roof and of course the consumption of the whole production facility. The key benefits is two. First one is reduction of reserved capacity from the grid, and second one is maximal consumption from the PV, which is produced electricity on the roof. This reserve capacity you can see in the bottom on the slide. There is mean value for the last year, so you can see how the battery storage system keep it the reserve capacity, and roughly we reduce this reserve capacity more or less of 40% down due to installation of the battery storage system. Battery storage system, of course, bring another benefits like off-grid operation. So it means if you lose electricity or power supply from the grid, battery storage are able to provide power supply for the whole production facility. And another important thing is the roof power plant is still working during this off-grid operation. And of course, the last thing is reactive power compensation, which of course reduce some cost as well. I prepare some shortly conclusion for the last 2 years, what we can saw in the data, what we have in this installation. You can see 2 years, 21 and 22, And in the first focus, you can see a very big gap between these 2 years. The main gap is caused by the price of the electricity, of course. Yeah, as you can see, in 2021, we have around 70 euro per megawatt hour, and in the 2022, it's roughly around 370 or 400 euro per megawatt. So this is the main gap between 2 years. But anyway, battery storage system, this key benefit, it's the storing extensional electricity which is produced from the PV. So it's mean if you not install battery storage system, roughly 90 megawatt hour it goes to the grid without usage in the location. So that is the main point for the battery storage system. And of course, the battery storage system brings some additional benefits. As I said, off-grid operation. During these 2 years, we have 3 days off-grid operation. It means the production facility was 3 days without electricity from the grid. So during this time, the battery storage and PV are able supply complete production facility, and this is not bring some losses from the production. So if we look to the payback time of this project, you can see in the second table, in third row, you can see payback time without subsidies. So it's mean if the project would not get some support from the government. And second one, or fourth row, you can see payback time with the subsidies. As I said, there is very big gap between year 2021 and 2022 due to price of electricity, and due to this big, let's say, price gap, the payback time will be, or it is reduced very rapidly for the half of the normal. Yeah. So that was first case study. Second one, I prepare a little bit different one. So this is battery storage system for the wind farm. This battery storage system was delivered in middle of 2021 and started in operation. This project consists of 4 battery storage systems. Each one have 1.5 megawatt power and 3.8 megawatt hour capacity. This battery storage is connected to the wind farm, to the windmill. Each one have 1 battery storage system because there is 4 new windmill, and this battery storage system is connected to each new windmill. The main cases of this battery storage system is charging the electricity from the windmill if the price in the market is low, and discharge when the price in the market is high. So we are working on Polish day-ahead market. So we predicted production from the wind day ahead and set up some charging and discharging plan for the battery storage system. As I said, the main benefit what the bring installation of the battery storage system is moving production of electricity from lowest priced hour to the high price hour. So this is the key benefit what is bring in this case. We can see some or another conclusion for this case study. As I said, we try to charge it battery storage system if the price of the electricity in the market is low and it's production from the wind, and sell it if the price in the market is high and usually production of the wind is low. So in the table you can see comparison for 2021 and 2022. We counted, of course, or you can see same big gap between price of the electricity and the spread in the market. This is main key value for this project. So it means with battery storage system we can bring more profit for the customer due to we shift electricity to the high price hour in the market. So that was two real case which is working on more than 1 year. And of course I'm ready for your question, and thank you for your attention.
Thank you, Tomáš, for the presentation. I have a first question from myself, and then I will look at the Slido. It used to didn't pay off to use batteries for peak shaving. You know, like a spread between cheap and expensive hours, because cost of cycle was larger than the spread between cheap and high prices. You know, usually when you have low prices, the differences are so small that it doesn't make sense. Now we have significantly higher prices. The spread is, you know, much larger. Does any of your customers using batteries for, you know, using the spread between the cheap and expensive hours? Is it worthwhile to use the batteries for such a business case?
Yeah. As I showed this second case in Poland, when we started this project, the price and the spread was very small. For example, we said about 400 Polish zloty. It's mean around 80 euro or something like that. You are fully right. It's not feasible for one. If I counted one cycle, what is cost of one cycle of the charging of the battery. But anyway, this is not only about this spread price, because the customer get, I don't know, green certificate. They are sell it such part of the energy in the market for some services through the seller, yeah, and they have another let's say future uses for this, yeah. So the main, let's say, the first thinking about why they bought the battery storage system is not only about the spread price in the market, yeah. This is, let's say, only go in this way, yeah, because the spread is very, very high right now. So it's mean every day they provide very big profit, yeah, from this. But we know during, I don't know, 1 year or maybe 2 years, the spread will be smaller and smaller, and they want to use the battery storage system in different cases, mainly for example, for the grid support services, yeah. So this is another case what should be used in this project.
Yeah. And the grid services, you know, the FCR, primary reserve, it's obviously it's got the nicest business case for the battery. Do you see increase in demand for batteries in this region for FCR?
Yeah, exactly. But problem, for example, in Poland, they don't have legislation for that. Yeah, there's legislation not exist yet for frequency control reserve. Yeah. So what I can see, for example, in the check, where we slightly move in this part, so there is big request for battery storage system. Mainly if you have, for example, power plant, so they want to install battery storage system behind the power plant and provide frequency reserve as the service. Yeah? Mm-hmm. So this is main cases what we have got.
Mm-hmm. Okay, understood. The question from the audience: what is the payback period of 1 megawatt battery at today's prices in ancillary services market?
It's question, yeah? Because 1 megawatt battery system, their purchasing price should be different, yeah? Because, you know, as I said, we provide tailor-made solution for the customer, because each battery system, it's quite different. You use different inverters, you use different battery, I mean, not only producer, but the capability of the battery. For example, 1C, 2C, and the prices of the components is different, and it means final price of the battery storage is different as well. But if we look, let's say, to the mainstream, as I said, I think we are under 8 years right now.
8 years?
Yeah.
Okay. And very last question. There is going to be a large investments in the renewables, primarily photovoltaics. I guess the requirements will be to have batteries next to the PV asset if you want to receive subsidy.
Mm-hmm.
Do you think that this will, on its own, lead to the much larger investments in batteries, and it will decrease the cost of batteries? Do you think it will create sufficient scale?
If we look to the price of the battery itself, I think is not influencing by that, because if I look 8 months ago, the price of the battery will be something, and today we have 30% more. Because producer, you know, who is producer of the battery? China, Korea, and that's all. There is no production in the Europe for the battery storage system. Only we have production, but for the cars, not for the battery storage system. And it means the price of the battery for battery storage system was increased from this year more than 25, maybe 30%. So I can see some decreasing of the price, in this case. And if somebody will, let's say, increase the request, how many megawatt they need, I think the price will be stable, because the Chinese or Korean is not, let's say, for that is not important what was the demand, because they are set up some production facility in such level, and if you have request double or triple, then the production facility is it. Why you reduce the price of the production? Does not make sense.
Understood. Why we don't produce batteries in Europe?
I see the main key thing it's the materials, and let's say lithium. Of course, we should say we have something in the Czech Republic, but it's not about the rocks or the rough material, but it's about the chemical industry, which is behind of that. So you must make the raw material, put to the chemical industry, produce something, and there is very good, large chain, which several steps when you then in the end it's the battery. So what's the missing? It's this chain between.
Right. Okay. So we have lithium in Sinovet, and the Germans have chemical industry, right?
Of course, it's true. But then you need some negotiation between the parties and find some conclusion.
Okay. I see.
And I think it's not yet done.
Okay.